LU factorization, also known as LU decomposition. Basically, what we want to do is we have a square matrix A, and we want to decompose this square matrix A into two square matrices L and U, all with the same dimensions. So the relationship here is that matrix A is equal to matrix L times matrix U. L is going to be a lower triangular matrix, and U is going to be an upper triangular matrix. So let's see a quick example of how a 4x4 matrix breaks down. So we have a matrix A given here, which I've written in terms of variables just to keep this more general. But when you do LU factorization, you will start out with a matrix A that has actual numbers in it. For now, we're going to keep it in variable form just so we can see how it looks generally. So we know that A is equal to L times U. L is, as I said earlier, a lower triangular matrix. So that means if we look at this main diagonal here, all the values we care about and solve for are in this lower triangle. So all the values along the main diagonal and below it. If we look at all the values above this main diagonal, they're all zeros. The values we don't care about. So you can see that it makes this sort of lower triangular shape, which is why it's called a lower triangular matrix. Similarly, if we look at U, we have the same sort of thing, only the values we care about are on the upper side of the triangle. So these are the values we care about, and the values below the main diagonal are all zeros, the values we don't have to solve for. And this also makes this upper triangular shape. Last thing to note is that your L matrix is always going to have ones along its main diagonal. So this is essentially what your template will look like for any LU factorization of A. You'll just have more rows or more columns, less rows, less columns, depending on how big your square matrix is. But they will always follow this pattern. So we have our matrix L and our matrix U. If we actually do matrix multiplication, so taking these rows of L, right, and multiplying it by these columns of U, you should get a matrix. You should get this exact matrix if you do the multiplication out. Highly recommend writing out each of the steps so you can see that yes, you are getting these individual terms and that this is the final matrix you end up getting. So now we basically have a relationship between this matrix we just solved for and matrix A. And this allows us to solve for our U1 values, our U12 values, L values, and so on, because we actually already know what our A values are going to be. So let's look at a more concrete example. Let's find the LU factorization of a 3x3 matrix A, where A has some actual values in it. So here we have A is equal to 1, 2, 3, 3, 2, 1, 3, 1, 2. So again, we start out with this LU factorization, the general format. We know that we have ones along the main diagonal. The unknowns we're solving for are down here, and the unknowns for U we're solving for up here. So if we do the multiplication, we end up with this matrix, which is basically the same as this matrix here. If we just take sort of this snapshot of a 3x3 within the 4x4 matrix. And again, you can actually do the math and make sure that, yeah, this is the matrix you get. And we know that this is equal to A, so we can put in our real values, 1, 2, 3, 3, 2, 1, 3, 1, 2. And so from here, we can see, yeah, we can solve for our U and L values now. This first one's pretty easy, U11, we can see that, okay, U11 is equal to A11, and A11 is equal to 1 here. So if we set up that equation, great, we already got our U11 value, which is 1. Same with U12 and U13, should be able to see this pretty clearly, that our U12 and U13 values are going to be 2 and 3 respectively. Now, if we look at this first column here, we have L21 times U11, and we know that is equal to A21, which is the same as 3. So we can solve for L21 here because we actually solve for U11. That's the first value we solve. So we have this equation, right, where we have something like, okay, A21 is equal to L21 times U11. But we already know what U11 is, we already know what A21 is, so we can solve for L21, which down here on the bottom left I've already written out. L21 is 3 divided by 1 because it's just A21 divided by U11. And so now we know that L21 is equal to 3. Similarly, for this bottom left case, L31 times U11, we know that's equal to 3, and we can solve for L311, we get that is equal to 3 as well. Then on, we can move into the very middle term. We have that L21 times U12 plus U22 is equal to 2. And we know what L21 is now. We know what U12 is now, so we can solve for U22, and we get -4. So you just keep going with the math here to solve all these other equations, and that's how you're able to get every U and every L value. So we end up with this final matrix L and this final matrix U. And if you actually do the math and multiply this out, you should be able to get back your original matrix A, which is 1, 2, 3, 3, 2, 1, 3, 1, 2. So one last thing to note about LU factorization is when you solve values, you'll notice that we went from values on the top row and the left column, so the very top row, very left column, sort of this like outer corner, we solve for all those values first. Then we solve for the values in sort of this inner quarter, and we kept going. We only had one more value to solve for the 3 by 3 case, but if you had a bigger matrix, you'd basically keep going in sort of this cascading style until you reach the very last term. So when you do LU factorization, you actually have to solve outside in, starting with the very top row and the very left column. And you keep following this format all the way down. And the reason for that is you'll notice as you go farther down into this bottom right corner of the matrix, the values down here depend on all the values you calculated up here and on the values you calculated down this way towards the left. So you do kind of have to go iteratively through these outside rows and columns into the inner ones because those values on the inside depend on those on the outside. So when you do LU factorization, this is sort of the path you have to follow. And yeah, if you do that, you should be able to LU factorize any matrix. So that's all I have for LU factorization.